Okay, now we're starting exercise 1.6, two-dimensional figures. There's a lot of new terms, new vocabulary we've not used so far, and there's a lot of work within this section. So what we're going to do is we're going to take a time with it, go over it, and make sure we've got a good understanding, because this chapter or this section of the chapter is the foundation of a lot more of the chapters that's going to come across. So looking at the vocabulary to start off with, the first one in the vocabulary is the polygon. Okay, so here is the information that will tell you what a polygon is. It's a closed figure formed by a finite number of coplanar segments called sides. Goes on to explain a little bit. All right, we've already talked about vertex, but the vertex of a polygon is obviously the vertex. If you look at the diagram, it's looking at vertex J. So get used to these new vocabularies. Try and look at the definitions of them. Use them all the time. All right. A polygon is a closed figure. You've got to make sure it's closed. If it's not closed, it's not a polygon. So look at the diagrams below. They've got 6 there that are polygons, 6 that are not. Anything with a curve is not a polygon. Anything that's not closed, in other words, if lines cross each other, it's not a polygon. So again, look at the definitions, look at what is a polygon, what is not a polygon. Okay, on this page we've got the general names of most of the ones of the polygons that you will use over the course of this textbook. Obviously you know about triangles, quadrilaterals, so don't forget that's a 4-sided figure, so things like squares, rectangles, rhombuses, kites, trapezium, they're all named as quadrilaterals. So get used to using quadrilateral as well as the names of the terms that you know. It goes on: pentagon, hexagon, 7, 8, 9, 10, 11, very rarely used, hendecagon, and anything over 12 is known as an engon. So a 13-agon, a 14-agon, a 56-agon. Okay, so remember, you know, as best as you can, these names. Okay, the next one, and the most important one, is what is a regular polygon. Well, if we go back to, you know, what we did in 1.4, 1.5, look for the notation in your diagram. If you look at the notation in this diagram here, angle A, B, C and D, they're all the same size angles. The line AB has got a line next to it part way through it, and the same as BC, CD, DE and EA, which means that it's the same size lengths, so that one is a regular polygon. Okay, before we get on to example 1, which is classifying polygons, let's talk a little bit about convex and concave. Basically, polygons will come in either one, either or. So to me, I look at little things, as you know me now, I look for little things. For instance, the last letters. Concave. If you think of a cave in a hillside or something like that, you go into a cave. So if you've got diagonals where a vertex goes in, then it's concave. If your diagonals are on the inside of it, it's convex. Simple, easy to remember. So let's have a look at the answers to this same problem. Okay, so first of all, name the polygon by its number of sides. It's just purely and simply counting them up. You've got 6 sides, so it's a hexagon. Is it concave, convex? Well, simplest thing is join the diagonals up. If I go across here, from here to here, then this is actually going in. So to me, that's concave. So it's an irregular hexagon, because it's all the sides, and even though the sides are the same, the angles are not. So it's an irregular hexagon, but it's also concave. So look for little tricks like that as you go along the questions. As you can see from the diagram, all the angles are the same. All the sides are also congruent. There are 8 sides, so it's an octagon. In theory, you should be rewriting a regular octagon. Okay, None of the diagonals from angle to angle are on the outside of the shape. They will all go inside the interior of it, so it's a convex regular octagon. And here we are with guided practice. Okay, there are 3 questions. You've got 1A is obviously a rectangle, B you've got a star, and C you've got a 6-sided shape. Have a go, see what you can come up with. What is the name of each polygon, and is it concave, is it convex? Here's where we start going through all the formulas that you will be using over the course of the geometry book. All of these at some point you should have come, should have come across. The triangle is a half base times whatever the height is. If you want to find, that's finding the area. If you want to find the perimeter, you add together the outside lengths. Similarly with the square, each length must be the same length for it to be a square, so you want for the perimeter 4 times whatever the length of the side is. To find the area, it's side times side, which is side squared. For a rectangle, to find the perimeter, you want 2 of the lengths plus 2 of the widths, or 2L plus 2W, and the area is just length times width. Circumference of a circle, usually, well, there are 2 equations that you will see in textbooks, either 2 pi r or pi d. Unless you are told otherwise, always use the pi button on your calculator. If you're told otherwise, it will tell you 3.14 or 3.142. It will give you what degree of accuracy they need. And to find the area is pi r squared. A lot of information on these 4 basic shapes, but you will be using a lot of these shapes all the way through this textbook. So have a go. Using the information on the previous page, what is the area and circumference, or area and perimeter of this particular shape? Then when you find the area of the rectangle, have a look at the circle that's underneath. See what you can come up with. Try and get it as a degree of accuracy as best as you can, using the pi button for the circle. And here is an example of how you set each of the equations up. For the perimeter of the rectangle, it's 2L plus 2W. Substitute it in and simplify it. So you will get the perimeter of 10.6. To find the area, it's the length times the width, which will give you an area of 6.72 square, in this case centimeters. For the circle, which is B, they gave you the radius of 3, so use the 2 pi r button, or the 2 pi r equation. Substitute 3 in for r, let your calculator do the rest. You finish up with approximately 18.9 to 1 decimal place. Finding the area of the circle, using the 3 again. 3 squared is 9, 9 times pi will give you approximately 28.3. Try and get them as accurately as possible. Pythagoras' theorem, another big one that we'll be using a lot in this textbook as we go through it. Remember what was said in class? The formula is a squared plus b squared equals c squared. You've used it already, or partially used it already, when we did the distance formula. Okay, so sometimes you're going to need to use the distance formula in order to find a missing side. Case like this, you've been given 2 of the sides. All you've got to do is use Pythagoras in order to find, in this case, C. Okay, so now we come to the solution. As you can see, the first thing that they always do is quote the formula. The formula is already there for you, so make sure that you quote the formula. So the formula is c squared equals a squared plus b squared. Make sure you quote the formula. Alright, they've told you the side lengths are 7 and 7. Substitute that in. Use your calculator And again, make sure you read the question to determine how or what degree of accuracy they need. You can leave your answer at root 98, that's sufficient for a correct answer, or using your calculator, 9.9. Now, we're going to find the perimeter. Again, we've got the formula, so again, make sure you use the formula and quote it. Two of your lengths, A and B, you've already used in Pythagoras. You now use the solution that you got to plug into the second of your equations. Adding them all together will give you an answer of 23.9. So now you find the perimeter. The area, a half base times height. Again, quoting the formula. Because it's a right angled triangle, you can use the two sides that they gave you, which is 7 and 7. Use your calculator if you need to, but 7 times 7 is 49, and a half of 49 will give you 24.5. Simple? Maybe. Okay, now we come to the big example that you will always find for area and perimeter. This time all they've given you is vertices, P, -1, 3, Q, -3, -1, and R is 4, -1. Take it in steps. Each step, take your time as you go through each step. You know me by now, I'm a visual person. First thing I would do is graph the triangle. Make sure that you label it and draw it very accurately. As you can see now in this step, what we're trying to do is use the distance formula again. And again, as you've just seen, it's part of your Pythagoras theorem. We've used the distance formula several times in exercise 1.3. And again, don't worry about which one's x1, y1, which one's x2, y2, because you're squaring both of your equations, so you're going to get a positive answer eventually anyway. Okay, in this case, because we're looking at distances, and you're going to use it in a formula, then make sure you go a little bit more accurate than root 20. Instead of leaving it at root 20, which you can for distance formulas normally, make sure you simplify it again to a degree of accuracy. Most of the time, 1 decimal place, which is 4.5 in this case. Okay, so here we are on the next step. First of all, from the diagram, we already know that QR is a horizontal line. You don't really need to use the distance formula from that. You need the absolute value of -3 to +4, and as you can see, straight away you can find that that length is 7. Easy to do. Okay, next one. You've got to find PQ. PQ is this line here. It's a slope, so you really can't do anything but use the distance formula. It's been quoted straight away. You've used it in 1.3. Substitute your numbers in, and don't forget what we said in class. It doesn't matter which way you put your x1, y1, because when you square it, you will eventually get a positive number anyway. Go all the way through, use your calculator if necessary. Honest opinion at this moment, don't leave it as a radical, simplify it to 1 decimal place. So using the distance formula, PQ is 4.5. Now we need to do PR, using the coordinates given, distance formula, quoted straight away, substitute in, let your calculator do your work, come up with an answer of 6.4. Okay, and as it says here, QR, without doing any calculations, is 7 units. Now you've got your 3 lengths, start putting things into the formulas that you need. The question, remember, was find the area of the triangle. First thing to do, quote the formula. Use the information that you've been given to find the area of the triangle. Okay? The simple one is to actually find the area of a triangle. Well, you know the area of a triangle is a half base times the perpendicular height. Remember this is, well, we already know the base, use an absolute value from -3 to +4 is 7. And again, you can count really. So we know that the perpendicular height must be 4 units to 4. So again, substitute in your 7 and your 4. 28, half of 28, 14.